My name is Natalie Lunbeck. I work for Shipyard. We're the ephemeral environments company, and I just recently moved to Boston. As of this Saturday, it's been exactly a month, so it's great to be here. Yeah, great to connect with the local Boston DevOps community. I'm super excited. I just saw that there's a Slack group, so I feel like, wow, this is the perfect time to meet everyone in person and, yeah, form new connections. So my talk, I wanted to talk a little bit about how good testing and reliability practices are really the foundation for your org and its stability as a whole, outside of your software. So let's kick things off. So I don't think we can start the talk without agreeing on a common definition of organizational stability. Sorry, my cursor's there. And what a lot of people tend to agree on is that organizational stability has two main things to it. You have your consistency, which basically means that when you show up to work, you're doing the job that was defined for you. You know what you've signed up for, you know what to expect day to day, more or less, and nothing extremely out of the ordinary happens. And predictability goes very closely hand in hand with that. Predictability means that anything that happens in the future is probably roadmapped. It's probably expected. And if it isn't, it probably won't happen because you have such stability. You have these processes in place that prevent things from going wrong, but if things do go wrong, you've rehearsed that so many times, you've prepared, you've practiced for it, that you're able to recover quickly and get back to that baseline of stability. So I know my talk had a very long title. I didn't want to reduce it too much further, but I think that it makes sense. It's conveyed very well through this pyramid graphic. So just visualizing that as testing and good practices as the foundation of a stable, strong org. So when you write tests, you're controlling the stability of your software. You're able to catch bugs, catch regressions, catch anything that might happen, ideally before it hits your customers and before it hits your code base. And that is one of the things, not necessarily the main thing that guarantees reliable software, but you essentially cannot have reliable software without that. And I know many things go into reliable software, but for sake of brevity, we're just going to call it software with minimal downtime. Because software, for many, if not all orgs, is the glue holding them together. So in order to have org stability, it's reliable software is absolutely requisite. But again, many things go into that. But once you lose your reliable software, you lose the stability of your org. And when you do have reliable software, you're operating predictably. You're efficiently recovering from any crisis, and you're not having any unexpected downtime, outages, and so forth. Okay, well, this might be a little bit obvious, but why is it such a priority to have stability in your org? And I think that you all can answer that better than I can. And I think, well, nowadays, I'm sure you hear this quite a bit, but every company, regardless of industry, is a software company. And I imagine that we're all here, we're all software professionals, but we're probably in a variety of industries. Some of us are working on a software product itself, a SaaS company. Some of us are in infrastructure. Some of us, just wide range of different applications and different ways that software is building up and holding our orgs together. So when you don't have stable software, that goes more beyond just your software team. That impacts your whole business, your whole org. And when it comes to your colleagues, it's not fair to them to not give them stability in life. You've hired them for a reason. They've been brought on for a reason. They're there to do their job. They know what they've signed up for. And if you're not giving them stability, you're giving them stress. You're not letting them do what they are best at doing. And, on a personal level, that's bad quality of life. But on a professional level, that's also very inconvenient because they're not able to be productive. They're not able to fulfill their career goals as contributors on your team. And then, of course, optically, having bad org stability, whether that's through your product, whether that's through your practices, this is very bad optics for your company. You don't want to be giving the impression of instability because nobody wants to be a customer or a client of a company that cannot hold itself together, because that foreshadows dangerous things. And then, of course, not just more costs in terms of infrastructure, remediation, and so forth, but you have unpredictable costs. Because if you don't know the extent or blast radius of a bug, you don't know how to budget for that outage. If you don't know how bad something can be, how can you forecast for it? So that's where it becomes really difficult to financially plan. So here are some personas that you might have around your company. For example, you have your users, and maybe you're an online store, or maybe you're an essential software as a service product. So best case scenario, if you're a store, perhaps someone goes to your store, tries to buy something, and they can't because you're having an outage. And, best case, they come back later, make that same purchase. But some outages are more critical than that. For example, maybe you have such a critical piece of software that your customer cannot afford for you to have any downtime. Maybe they check in on your service, it's down at a critical time, it causes them like a ripple effect impact to their business, and they can't afford to have that type of uncertainty in a product that they're paying for. So that might be, the breaking point for them. You lose a customer, you lose a client, and that is something that by all means you want to prevent anything and everything that can, in that terms, downtime can be the worst thing that can happen for your business. And then of course your employees. And I talked about this a little bit earlier, but it's not really unfair to them because they've signed up to do their job, they're trying to get their goals fulfilled, and yes, maybe like one afternoon outage working overtime, maybe that's not the end of the world. It might not seem like it, but if this stuff starts to pile up, that adds up, that brings them behind on their goals, and that burns them out. And just, on a personal level, it's not fair for them to be dealing with that. And then probably not top of mind, but you do have your competitors, and this is a very convenient opportunity for them to kind of amplify your outages, your bugs, your instabilities, and kind of advertise that, hey, I don't have that same problem. And that's, the last thing you need when you're struggling, trying to remediate something. And then, of course, you have just the world, which is, word of mouth from your users or any press coverage you might get, because you have probably spent years, decades, months, however long it took for you to build up your brand's credibility and your image and this strong presence. And if you're starting to get not bad reviews, if you're starting to get headlines about yourself, that's something that you want to make sure that you are doing everything you can to counteract, because it's a long tail effort. Because maybe the first time someone's heard about your product, your software, your company has been in the event of something going wrong like this. So I wanted to talk a little bit more on why software stability is so closely tied to organizational stability. And as we talked about, downtime is just about the worst thing that can happen. It impacts your customers, your product, your business, your optics, all of the above. You want to prevent that by all means, because you as a company, you are a software company, and you want to make sure that all your teams are functioning as expected, not just your software teams, because this might impact your customer support, it might impact your marketing, it might impact your sales. It's an incredibly wide-reaching effect when your software isn't working as expected. And then, of course, it's hard to budget for outages, both financially. You're going to have perhaps increased cloud costs, remediation, and then also just otherwise. You're going to get people behind on their quarterly planning. You're not going to be hitting the goals that you're hoping to hit. And that's really difficult to estimate where to put people's time, especially when it's org-wide and it's not just, isolated to a single team. It's not just your SRE team. It's not just your software team. It can be your C-suite. It can be just any far-reaching ripple effect. And then something that many orgs with stable software take for granted is they don't have to walk on eggshells when they're building new features. They trust their deployment pipeline. They trust that anything they push is more or less going to make it to production safely, and that allows them to take more creative risks, allows them to build faster, build more stuff, and do what they do best. Because if they're not able to do that, they're firefighting, they're fixing bugs, and that is very difficult to make progress or productivity that way. And then, of course, you're maintaining customers' trust and expectations. Because what I like to think about is, for example, when you go to Amazon.com and you make a purchase, how many times has that ever gone wrong for you? And I can maybe think of like 1 or 2 times in my life that I can remember that not working. But you kind of go in with that expectation that it's going to work, and the thought or idea of it not working doesn't even cross your mind because you're so used to having such a painless, frictionless experience. And if you can guarantee that for your users, it's very nice. But it sticks out I think it's very easy for reliable software to be kind of recessive, like in the back of their mind, they're not noticing how reliable your software is, but the moment that something goes wrong, that is something that's going to stick, and that's going to taint the image of your software and its credibility. So I talked a little bit about how when you're stable, you can optimize and aim for performance, not just stability itself. And I know in 2018, Google's DevOps research and assessment team, the DORA team, also behind DORA metrics, they hypothesized that making changes and implementing good automation and reliability practices would lead to an improvement to overall performance. And in 2022, they were able to conduct the research to back this up. And this is one of the figures that they came up with. They call it a J-curve, which I see more or less. But you can see that it's a continuous process. It might take months, it might take years for you to get to the point where you want in terms of your stability, but it does pay off, and it's a worthy effort to make, because you can see in the beginning, you can do quick and easy automation practices, get yourself up to that next level. But then as you start to get deeper into your code base, start working with tech debt, of course, it becomes more and more intensive. You're seeing less immediate productivity gains. But then, sure enough, if you're still plugging away at that, still making that concentrated effort, in the end, you end up obviously much better from where you started off. And you start to see those positive effects, not just like in the amount of code that you're pushing. You see that in the reliability of your code. And you also just see that in your team's happiness and quality of life, because they feel like pushing code through the deployment pipeline and making sure that it's stable isn't as much of a chore as it had been in the past. They can really trust their deployments. So when we think about it this way, we can talk about what, as developers, many of you maybe are developers. I also have the next slide for managers, but what your exact role and stake in your software's reliability might be. So as a dev, one of your, of course, not your sole purpose, but one of those is writing good code and reliable code. And maybe your org has a QA engineer who works with you to test your code. And one of the ways to kind of bridge this gap and make your code as reliable as possible is making sure that you're collaborating with QA at every opportunity that you have. This should be kind of done on the spot. You understand the context of the code you've written better than anyone else can, so you should absolutely be a major stakeholder in that testing process, writing and architecting those tests and just finding edge and corner cases and working with the QA team to do that. Or perhaps you write your own tests. That's great. Just make sure that you do them as soon as possible and making sure that they go out with the code itself, at least initially. It's very important to guarantee that, because that's how we can control the stability of our software. And then, as I said earlier, like this is how this has a very positive, strong ripple effect to the overall stability of the org itself. But I also think that I've been reading a lot of interesting things these past few months, that you as a developer pushing a bug to production isn't necessarily your fault as a developer. because it's the responsibility of your org and your team to make sure that you can push things and take risks without having something with that much power to take things down. That should be an optimization for your deployment process. So yes, you can do what you can writing your automated tests, but there also are some process improvements that should be in place as guardrails to prevent something terrible from happening, because your code, your tests should be able to catch anything possible that can go wrong with your code. And if your tests can't, then that's where your other reliability practices come in. And then as a manager, you're there to enable your devs. You're a team. You're working to make their lives as easy as possible, and making it as easy as possible for them to test their code. And that is done by investing in developer experience. And I think that many of us know that when something is easier to do, you're more likely to do it. If you had a really difficult testing, or maybe you're running your tests manually, all these manual steps, anything that's a lift, you might take that shortcut on smaller like hot fixes or smaller commits that you're getting through your pipeline just because you feel like you might not need that. And then of course, that becomes a slippery slope very quickly. So doing that, making it as painless as possible, and of course, collaborating with your developers because they know what they need, they know it will make life easier for them, and then also just doing your research into what other precautions or repeated practices they might want to take within their pipeline, and finding ways to integrate those and make them developer friendly. So I talked a little bit about automated processes outside of testing, but I think that it comes down to, at a high level, these are some of the most valuable ones that are, somewhat easy to implement. And of course, you have your main CI/CD pipeline, but what you can also do is you can implement smaller, less complex CI/CD pipelines earlier on in your pipeline, in your deployment process. And maybe you run validations at the commit level. Maybe you're running unit tests earlier on, prior to pull requests, but just making sure that any repeated processes that you'd want to do anyway, you can pretty easily integrate them there, and just not underestimating the value of that. And then, of course, your test suite itself, which is, ideally in a perfect world, you're writing and building this out, fleshing it out during development, and making sure that you have end-to-end code coverage, just because your end-to-end tests are going to be one of the most valuable, reliability practices that you can have here, just because if you're trying to simulate customer workflows or user workflows, that's really difficult to do manually. It's time consuming, and are you going to do the exact same workflows every single time on every deployment? Probably not. So that's why if you can offload all of that into your end-to-end tests, you're saving a ton of time there. And then, of course, you have SBOM or security scanning, because dependencies change, vulnerabilities can be introduced. So just making sure that you're not doing that too infrequently. Ideally, you're doing that with every deployment, just to make sure that you're keeping track of what is changing here. And then multi-stage builds. If you have any build tools or development tools, maybe you're baking them into an earlier stage of your Docker image, just so they're not, they don't have that vulnerability opening when they're in production, just because you don't need them then. So you might as well reduce the amount of things that you have overall. And again, you have to make these dev friendly if you want devs to use them. So how do you do that? And your developers can tell you that. That's something that you want to facilitate, either a Zoom call, an in-person meeting with. See what would make their lives easier. They have these workflows that they've been, this is their day-to-day. So finding what's blocking them, what are the obstacles there, and finding ways to improve that. And then knowing that this isn't just like a one and done thing. This is something that you're going to revisit maybe monthly, maybe quarterly, and just see how their workflows have changed, and see how they're feeling. See if there's a certain part of the pipeline that they tend to get blocked at, and if you can find a way to support them, enable them, and reduce friction. And maybe even just finding time to, roadmap some changes to your pipelines, changes to your processes. And then this is another graphic from Dora's research, and I really like this model of deployment pipeline, particularly in the way that they've struggled it. I don't know how, I guess you can read that. I think that what's nice that they're doing here is they have several different stages, and this is, in each stage allows them to go right back to the inner loop. But each of these stages is kind of bite-sized. And as you get further along the pipeline, the stages get slightly more complex. And so that way, the most complex stages are being executed the fewest amount of times. So for example, like the first stage, you have your commit that maybe doesn't pass your validations in your first stage CI/CD pipeline. So you take it back to square one, you iterate, you fix that, and then it does pass that, but it doesn't pass your automated tests. And then you keep iterating until once it passes all like the automated checks, then you have your manual intervention. Because there are two reasons why you want to be very mindful of your peers' time when it comes to code reviews or manual tests. Well, one is their time is valuable, and you don't want to have them reviewing a PR, 3, 4, 5 times when you can only have them review at the very last minute, right when they need it, and for things that cannot be offloaded automatically. But also because sometimes the biggest and longest bottleneck in a pipeline is humans. And that's a good thing often. I mean, we're not able to to do something, complete a task on demand. We have lives, we have other things to get to, but making sure that you're reducing that human element, and your colleagues will thank you because their time is very valuable, and you want to make sure that you're not having them check something again and again when they could only maybe be the final stage in the pipeline. So with a pipeline like this, in a perfect world, if you had a feature that made it through this pipeline, all green, got deployed, that feature would have a very, very low likelihood of introducing a bug into production. But if you're starting to see bugs in production with a high quality pipeline like this, maybe it means that you need to add another stage to this pipeline. Maybe it means that you need to make one of these stages stronger. Maybe you're not running enough end-to-end tests at the middle stage, or maybe you're not running it past enough people for code review. But that's something that you're able to iterate on, and you're able to build this out as you go and learn from it. So I wanted to end this on kind of like a call to action on how you can really go from here. What does your software stability look like? And I think that the only way to truly know how your software would survive an outage is to go through that outage and recover from it pretty quickly, and then you know that your org is stable. But of course, that's a pretty high-risk scenario. So if you want a pretty fast way to estimate this, you can look at 2 of the 4 key DORA metrics. You have time to restore service and change failure rate. And these are two of the final ones that are more reliability focused. So time to restore service, quick recap, that is when you do have an outage or regression or bug in production, how quickly can you remediate that? And DORA says that the best teams can do that in under an hour. And then change failure rate is what percentage of your deployments cause a regression. And that is kind of a measure of your deployment process or your pipeline, like from the last stage. If they're getting through that and still causing regressions, then that means that your pipeline needs to be improved. But what I like about these a lot is they're relative to your org. They're kind of a template for continuous improvement. Like, yes, there are tiers for elite, high, DORA metrics, medium, but the best way to use these is just set a benchmark for yourself. See where you are and raise the bar a little bit and see if you can improve your processes, communicate with your teams, and see if you can hit those achievements in a couple months. And then just raise the bar again. Because depending on your team, you might not need the same DORA metrics that another company needs, just depending on what you're trying to accomplish. But if you're doing pretty well on this, it's a pretty direct and safe ballpark measure of how stable your org is, at least when it comes to the software that's holding it together. And then, of course, last but not least, when we're talking about developer experience, you want to survey developers on their tool set. You can conduct developer experience audits, which is incredibly valuable, just finding out like how developers are doing in terms of cognitive load, how they feel that your internal documentation is, how they feel enabled with your tools. And you can conduct these on maybe a monthly, quarterly basis and see what can improve. But again, your developers are going to be the best measure of that. All right, well, I wanted to thank you very much. Thank you so much for tuning in, and I hope you've been having a wonderful morning at DevOps Days Boston. It's been an absolute pleasure to be here. Again, my name is Natalie Lunbeck. I'm with Shipyard. You can either email me if you want to chat, or you can find me on LinkedIn. And I'm looking forward to the next day and a half of this exceptional conference. Yeah, I think we have time for a couple questions. Yeah. Yes. Yeah, unfortunately not. They have shipyard.com. Shipyard Brewing, they sponsored my college reunion. So it was a little sad. Yeah, we'd love that domain, but they're great beer. Yeah. Yes. That's a good question. So often it can be managers, or it can be some organizations will have like an engineering enablement team or a developer experience team, and they're in charge of kind of that internal developer experience. But it kind of varies. But the surveys for developer experience aren't incredibly complex to design, so it can be something that maybe even just a team member takes the lead on. For sure. Oh, one more. Yeah, I mean, I think that canary deployments, I guess I'm more familiar with blue-green deployments, but that's a similar concept, if I understand correctly. I absolutely something to have in place because you want to just reduce the opportunity for bugs. Like even if something does make it through your pipeline, you can never be too sure. So I think that doing a rollout like that is, yeah, obviously this is not a supplement for something like Canary.
All right, let's give Natalie a round of applause.